Hello everyone, welcome back to the live session. Sorry for the delay. There was some technical issue. I was resolving it. So now everything is good to go. So let's start without any delay. Here we go. All right. All right. As I have posted yesterday, we will continue the further lessons on the machine learning. So I have made some changes. Uh, Today we will discuss in detail about the classification and regression and what is train and test split, why this is important with the example. And then we will continue in the next session about the data leakage, data pre-processing steps you need to take and you need to keep in your mind when you start the pre-processing at an intermediate level. So today's topic is at an intermediate level because in the previous sessions we have covered the broad picture, right? We did very simple, we took a very simple example and then we did the code section too. Now this week we will focus in detail on each and every step. Okay, and let's start. And if you have any question, feel free to post in the chat. And I have today one or two poll questions for you. So if you answer that during the live session, that would be much appreciated. Okay. All right. So this is the recap which we have covered in the last previous live sessions. What is machine learning and its type? We have discussed it in a at a broader level, right? Machine learning life cycle, what type of machine learning? It's a different type, supervised, unsupervised, reinforcement. So today I'm going to pick up one type, supervised, and we will discuss it in a detail. What is the like important terms of statistics? We have also discussed it. Okay. As I have told you, we will keep on discussing the important terms when we will jump on to the next level of the coding. So now it's a time to start with the today's agenda. So today's agenda is what is supervised machine learning. Okay. If you remember, we did it in the last session too. You can write down the definition. If you have an idea, I'm not like expecting from you the very technical like the definition, just to post it as a layman. Okay, what is regression and classification? This is we are going to discuss in a detail today. What is train and test split, why you need it, we will discuss it in detail. Why we do the train and test split. Okay, all right. So what is supervised machine learning? Do you remember we did it in the last session too? What is supervised machine learning? Okay, so look at this one. Let me select this color. Okay. So supervised learning, okay, works with the labeled data. If you remember, we did it, right? Labeled data. The model learns patterns like if this is, then that. Okay. If the input variable X are given, the model predicts the Y, output Y, right? Look at this example. So this is the your data set of the sales. So if the number of advertisement are 5, then the total sale will be done of $100. If the number of advertisement are 10, then the number of total sales will be $200. So we are just telling the machine if this is the input, this will be the output, right? So we are providing the answers too. If we connect it with the again the layman example, if I am giving you the question and answer too, right? So you are understanding if this is the question, this will be the answer, right? So tomorrow, if I will take the test of you, then I will only give you the questions, not the answers. And if you found the question, then you will write the answer, right? This is the way. So everything is happening under the supervision. Okay. And here, this column, this is known as dependent variable, and we denote it y. And this is, we also call it target variable too. And we here we know the answers. And this is the independent variable, which you use to predict what how many sales will be done based on this. Okay, so this is called independent feature 2, and this is called dependent feature 2. This is called your feature variables 2, and we call it target variable 2. Okay, if someone is using dependent variable, target variable, this, just understand it, this is the same meaning. Okay, so this is the just definition or overview of the your supervised machine learning. Okay, now if it makes, if you like got it, what is your supervised machine learning, just write down the like the answer. What best describes supervised machine learning? So number one, number two, number three, number four. So just type the number. What will be the answer? First, second, third, or fourth. Okay. Just type the answer in the chat. That will be much appreciated. Okay. So you have a four choices: learning with the label data, X and Y, learning without any target variable, learning by trial and error only, not sure yet. Okay, if you didn't understand it. Now we will move to the next step. So what is regression? Do you have any idea what is regression? We have discussed it at a broader level last in the last live session, which predicts the whole number, right? So here we are with the example. If you remember, right, we talked about when you are going to predict the whole number, it can be in form of float, numbers, integers, like a whole number too. If you look at this, when the goal is to predict a continuous numerical value like a float, right? Or it can be the whole number. The model can output any real number. That is called regression. At a beginner level, students often get confused between regression and classification. This is most important concept. So if once it is fit in your mind and it's clear in your mind, then it will never, you will never face any problem in future. Okay. Right now it will look easy whenever I'm explaining it. But in real time, if I'm giving you the two problems that looks like similar to your class, like a regression, or similar look like you might think it's a classification, then you got confused. Okay, it's get hard to decide whether it's a classification problem or regression problem. I will show you today where students most oftenly stuck. As I told you in the previous session, I will give you the example. Today is the time I will show you. Okay, so here you can see number of bedrooms and selling price. So can you tell me, in the previous slide we have discussed what is independent feature, what is dependent feature? If you know and you understand it, just type in the chat what is independent feature, what is dependent feature. Okay. But here I'm going to tell you this is your independent feature. So we denote it with the X in the machine learning world. And this is your dependent feature. This is you want to predict. You always want to predict the Y. Okay. And we call it target. This is independent feature. Okay. And this is dependent feature. So so dependent feature means you cannot predict this value without the help of this one. That's why we call it dependent feature. Okay, and this is independent feature because it doesn't matter. You don't want to know what will be the value of the dependent feature, right? You can predict the price of the house based on the number of bedrooms, but you cannot like predict the number of bedrooms based on the price, right? So this is the voice of like the case. That's why its name is very self-explanatory. What does it mean? Independent feature and dependent feature. If we draw it on the chart, Look at this. So this is your X and this is your Y on the graph. This is your selling price and this is your number of, sorry, bedrooms. Okay. So here you can write down 2, 3, 4, 6. And here is the selling price. Let's start from the range. We can start with the minimum 120K, then 140K, then 150, 160, and 180. Okay. So if you have the number of bedrooms too, okay, and the price will be here, your dot will be like this. Okay. If you have a number of bedrooms 3, then the price will be this, then the dot will be here, right? It will be here. This is I'm showing you actually as a layman. Okay. But there is a formula for the your regression. Y is equals to mx plus b. This is your target feature. This is you want to predict. This is a mathematical formula, okay? And this is your intercept value. Sorry, this is the intercept value, B, from where your graph is going to be start. You can make it any value, okay? 0, 1, 2, whatever you like. And this is your feature value, like number of bedrooms, 2, 3, 4, 6. And what will be this coefficient value? Okay, and this will be decided by your model will be keep on adding the coefficients value, penalties and everything and weight into the each features, multiply it and keep on adding, calculating and find out this value, okay, in prediction. And if here this is just a bigger broader picture, mathematical, okay, but how you calculate it, there is a formula. Okay, here we have the fourth and the price is 180. Where can be the price 180 here? Okay. So here with the next. So we can make it more bigger. And here we can write down the maximum price, your 500K. Okay. So everything liable between this. If you have a number of bedroom 6, then the price is around here, right? There can be the more data points, right? Some house prices is this. So when you are trying to, your model is trying to draw the line, it will be something like this in the form of regression. Okay. If the number of the bedrooms are increasing, then the price of the house is also increasing. Okay. So this is called regression. So you are trying to predict only the whole number, right? You are predicting the whole number and based on the given independent features. If you remember in the last live session, if you did not watch, you are watching this session first time, you can watch my previous live session where I have explained the correlation. If one independent, this feature is increasing, your target value is also increasing. This is also reflecting your positive correlation. Okay, so I'm connecting it with the that one too. Okay, so this is called a regression actually. This is a whole and detailed picture about the regression, and this is the mathematical formula. Okay, so here this is working with this formula. It will keep on predict adding the weights, coefficients weight, increasing, decreasing. Why it is increasing and decreasing the coefficient weights to predict the around correct value. So it can fit this line close to the all data points. Okay, it can there can be the more data points too. Okay, when we will do the coding section, then we will discuss more mathematically part 2 before I start with the coding section. Okay, just try to understand the now the formula, what is regression, how it is working, how it look like on the graphical, and what does it mean continuous numerical value. Okay, and now if you have any question, you can type the question in the chat. Okay. You can also think about the regression examples in the real time. So this is the most common examples I'm giving you. This is we have already discussed predicting the home prices because you are predicting whole number, floats number, right? Price can be in a 3.5 lakh, right? Forecasting the total sales, number of advertisement. You are predicting the total sales based on the given features. Estimating the stock values. This is a very popular example. Measuring the age and height, measuring the temperature, forecasting the temperature. You can type any other regression example in the chat if it is coming in your mind apart from these examples. Okay. Here I will give you the tip. Whenever you are learning or understanding any topic in AI or data science, if you keep in your mind what is this, why it is happening, what will happen, then it will open your mind and it will help you to understand the topic at a deeper level. Right now, it might seems to you it's a very easy regression, okay? But when we jump in the real time, students most often get stuck just because of these small basic ideas are not clear. Okay, so that's why I am like a focusing on the even the small basic point too, so you don't stuck anywhere when we are going to jump onto the in detail the intermediate level coding example. Okay, and now we will clear this and move ahead. Now we will talk about the classification. If you have any idea, just type in the chat. Okay, what is classification, how it is different from the regression. Okay, so here we are talking about the supervised machine learning classification problem. Okay, when the goal is to predict a category, also known as a class 2. This means when you want to predict the category, it is also known as a class 2 that come under classification. We will do the comparison to with the regression again, so you will have the clear vision. Look at this example. So if you want to predict whether the email message is spam or not, right? So there are only two values, whether the message will be spam or not spam. Is it whole number or like text data, right? So this is the text data, this is class, this is not whole number, right? This is not going to be whole number. Okay. So buy these fields, this is spam, win cash prices, this is spam. So if this is kind of the message, then this is not spam. So when you have this kind of the problem, this is called the classification problem. Here I'm not predicting any whole number, right? I'm not saying this is going to be 1, 2, 3 or some float number 1.1, 2.3, 3.3. No. Okay. This is we are just checking this is spam or not spam. So what kind of output is this according to the binary data, according to the data variable? If you remember the Python data variables, we did it in the first session. Remember? You did the binary data type, which contains that only two values, 0, 1, positive, negative, right? Yes, no. Only two outputs. So this is the binary output. So when you have the binary output, this is called a classification. Don't get confused here. This is the point where students get confused. Right now, I'm showing it to you spam, not spam. But what will happen if you don't have a this value, you have a value something like this. Let me make a one more table. So this is your email message and this is your class. You can also name it category too. There is a no harm. Okay. Let me make it clear. Sorry about that. So this is your email message. This is your class. It can be target name with label with the name. It can be any name, okay? It can be category according to the stakeholder or whatever data you are getting. I'm just giving you the idea, okay? So here, this is the message one, message two, message three. So message one, if this is a spam, we can keep it 0. Okay. If this is spam, 0. If it is not spam, this is 1. Okay. So now you might think this is the numerical, this is the whole number, this is integer. So this is going to be regression problem. This is the most common mistake done by the beginners in the real time. If I am giving you the data set, I'm telling you the goal, then there will be the no problem. You will solve it. Okay. But in real time, sometimes you got a data and you will see the output like this. And you don't know right now what is the goal. You are just saying predict category. If you see the numbers, student most often did this mistake. They apply the classification model on this instead of regression. Okay. So there can I am just showing you the only two categories, right? But there can be the more categories. I will give you the another example. We will clean this. Okay. So look at this. We will take the iris data set. This is a petal length. This is a petal width, right? So there was the three classes, right? 0, 1, 2. Versicolor, Virginica, right? And Setosa. So this was the values. Remember, it's a multi-classification. Now you got confused again. It can be the regression problem if you don't have a clear understanding about the difference between the classification and regression. You will say it is increasing, right? 0, 1, 2, it is increasing. So you will might consider it as a whole number, integer. So you will apply regression, which is wrong. Okay. So this is the like the point where student get stuck, or sometime it happened they did a mistake. So you need to take care at this point. Okay. Try to understand. You will never get the data something like this in real time. The data will be very messy. Okay, this is just you are at a learning stage, so we took these examples so you can have the better understanding. This is the reason. But I have uploaded several videos in a previous months too, which I have taken the complex data sets too. Okay, so I am going to take the complex data too, but in the advanced level. Right now we are at an intermediate level, so we will work on the intermediate level now. So I hope it makes a sense to you, right? What is classification and how it look like on the graph. So this is your here classes or X feature, sorry, X feature, independent, this is Y. Okay. And now when you are going to predict here, so let's say here is a email message 1, 2, 3. Okay. So here this will be the actually category. Okay. So there will be the this is not a trend line actually now. In the regression, you were just drawing this line, we call a trend line to regression line too, but in classification, this is a separation line. Okay. So here will be, let's say it's a spam, it's a not spam. Okay. So here will be the like message 1, message 2, and this will lie the message 3 under this category. Okay, so this is the way how it works. Okay, so this is we want to classify. So I'm just drawing it here. Why? Just for your understanding, but we want to classify. Okay, but this is going to be your classes. Okay, so it will look like this. When your model will, you will apply the model, how your model is going to group the data, right? This message belong to this class, this message belong to this class. This is going to classify, then it will predict. Okay, then you will get the output. So this is the classification. If you still have any question, you can clear your doubts. Just post your questions in the chat. This is the main goal. I'm doing the live session so you can get the answers at the same time. Okay. And now this is a classification examples. Look at this medical test result, whether the patient is having a heart disease or not, whether the patient is like a diabetic or not. Mhm. Animal classification, is this picture of a dog or cat? Because here you have a two classes. Okay. Here you have a two classes. Price range, low, medium, high. This is more than two classes. This is multi-classification, right? This is not binary output. So you are going to get a low, medium, high. You can convert it into 0, 1, 2. Or if you want, you can make it 1, 2, 3. Choice is your, okay? And the tree species identification, you can connect it with the iris too or other examples too. Okay, just think about the other real-time examples too, where you can connect with the classification example in a real time. How much you are going to connect it in the real-time examples, it will give you the more clarity. It will give you the more understanding. Okay, so now we will clear this. Here we go. So this is the knowledge check for you. Just look at this. Predict whether the patient has a heart disease or not. Is this a classification or regression problem? Look at the target too. Just tell me this is your target and this is your independent feature. So based on the age and sugar level, you want to predict whether the patient is diabetic or not. You can type the answer in the chat. Okay. So like I hope you will type the right correct answer. Okay. But if I give you the another example too, look at this. So here I have the pictures of the different type of the flowers. I have the here I will write down plants. I have a rose, I have a lotus, I have a lily, I have a any other flower. I no name is coming in my mind, so we write down one more name. Okay, so I have a these. Okay, and this is the feature. This is x1, x2. So these are the values. Okay, so based on this, I want to predict whether this is a rose, lotus, lily, or any other flower. Okay, we can make it other category. Okay, so tell me, is this a classification or regression? So just tell me. Okay, type the answer of this question too. Okay, all right. Okay, so now I'm using this term train and test split since first week, like a second video, right? When we started a discussion about the machine learning, I told you there is a train and test split. Remember, this is the most important part. If you remember, at which step this part come up in machine learning life cycle? Do you remember? What did the machine learning life cycle? Now type under what step of machine learning life cycle this step come up. Tell me. If you watch the all videos, you are watching it and you have a little basic understanding about the machine learning life cycle, just type the answer. Under what train and test split come up? Of the which step machine learning life cycle? Okay, just type the answer. So now we have a discussion about this. So this is the just consider it. This is the whole data set. Okay, it can be any data set. This is whole data set, right? So you divided it into the two parts, right? I showed you in the previous slides too. These are your independent feature and this is your target feature or dependent feature too. You might see here we also call it independent array features too. If you listen this is more technical word, then don't worry about it. Why we call it array? Because your input data will always be in the form of array when you are giving it to the machine. Okay, and we also call it vector, target vector data too, because this is just a single dimension. This is multi-dimension. Okay, I'm using it right now, the more technical definition for that your independent and dependent feature, because when you are doing the coding and if you stuck somewhere, you got something these kind of arrays when you split the data. Array is given two features, but you are passing three, you are passing one, something like this. So student got confused in this. What is array? Where is array? So this is array. You are giving the input. This is multi-dimensional data, right? You are giving more than one dimensional data. Three features, four feature, five feature, six feature, 10 feature, right? And the target is only one. Okay. So this is called when you are dividing this data, okay, into two parts. Okay. That is called train and test split. But before that, I'm just repeating this more technical definition about the independent feature and target feature. Okay. And if you remember under what step of the machine learning life cycle come up this step, just write the answer. Okay. All right. So now this is the house sale price example for the supervised machine learning for the train and test split data. Okay, so we are starting with this example. Let's say you have the area of the house, you have the number of bedrooms, you have the number of bathrooms, and this is your target. So you are going to predict the sale price based on the given these features. So what if the area of the house is going to be 2000 square feet, number of the bedrooms 3, number of the bathrooms 2, then the price of the house will be 500K. Okay, here we are just predicting the sale price of the house. Okay. And now we will continue this example. Why we split the data set. Okay. We will try to connect it with the same example. I showed you that example. I showed you what are features and target of the house sale price. Now look, assume it here with that one. Okay. Now this is your house sale price full data. Okay. This is you have divided. So you had a three features: area, number of bedroom, number of bathrooms. Three features, independent feature denoted by x1, x2, x3. Okay, and this is your target sale price. Now we are dividing it into the two parts. Remember in the iris data set we use this method from the sklearn library. Train underscore test underscore split. You pass the x and y and random state. Remember, you pass the test size to 20%. So this is the output, something like this at the backend. Okay. So it will divide your data into x underscore train, y train. We declare these features. Remember, right? X underscore, sorry, test, y underscore test, right? Equal to this one. So it will be divided this one into these two parts. So this portion, X train, Y train, your model will use to train the model. If you apply the regression model, let's say logistic regression, we use it for both, right? Logistic regression, either you apply the multilinear regression, linear regression on the house sale price data, right? So it is going to use this portion, X train, Y train, to train your data. Okay, so let's suppose you have 100 records in total. Okay, 100 records. This is 100 records, 1 to 100. Okay, so now if you set the test size here in this feature, test size 0.20. So Y train is going to be, this will become your 80 records for the train, 20 records for test. So this data is going to be hidden from here, hidden. We will keep the hidden this data from your model. If you apply here linear regression model, so your model does not know we have a more 20 records too. It is hidden from this data. That's why we split the data. This is the reason you split the data, because you want to hide the test data from the trained data. Okay. uh, from the trained data, so your or from the model, so your model does not know the answer of these data and what kind of the data we are going to give it. This is the reason. Okay, so it will divide this data into this. This is the reason you need a train test split method when you are applying the model, and you always need to split the data when you are applying the model. Okay, and now your linear regression applied on this, it will learn from this. Like if it has the area of 2000 square feet, number of bedroom 2, number of bathroom 1, then the price will be 500K. So this is learn, build the relationship between all these features here. Learn. If this is the input, this is the output. This is the input, this is the output. This is the purpose of your train data. Okay. And now what the test data will do, once you are done with the model, it predicts some values, right? It will give you something. Now you will test it with the test data. Okay. You will give these values and it will predict the answer. Okay. You will not give this one right now to the model. Okay. You will give just this input. Whatever it will predict, this one. So you will get some answer. We denote it with the Y cap. Okay, Y predict. Okay, let's say if you, let me clear this all. Okay, so let's say you here the values, number of sorry, area is 1000 square feet, number of bedroom 2, bathroom is 1. Okay, you have put this into the machine. So now this is your trained model. Okay, you have given the input of these three features into this model. Okay, you are not giving this, forget about it right now, we will use it later on. Okay, this is the testing mode. You are giving this feature and your model predict the output. The value of the first this 1000 is, let's say it is saying 200K price of the house. Okay, but corresponding to at a original, right, we denote it with the Y cap. This is predicted by your test data, by the model. Okay. So now you have a y underscore test value here. So here your actual price, which is, you know the answer, right? So here, what was actual price? Let's say 199K. Okay. But your model predict 200K. Now you will compare it. You will compare it with this one. If it is close to this one, here is your X feature. This is Y. Okay, so it is going to be like a plot a dot here, something here. Let's say the price is predicting this and the actual price is 200, but it is predicted 199K with the how many area? Let's say 1000 square feet. So the price will be here. This is predicted by your model, but the actual data is here, right? So this is a way how at the back end actually it works. Okay, that's why you need a train and test split. That's why we create these four these arrays or variable, and we will use x train, y train to train your model. X test we pass the model, and whatever value it is predicting, we will compare it, evaluate the model using y test. And this is your main goal actually. Okay, your goal is this, right? If you are building a model, what is your goal? Predict the house sale price based on the given feature, right? And it should be close to the actual price. This is your goal. That's why always focus and keep in your mind this is your most important step. Your testing performance and training performance of the data. I'm not saying you need to ignore this. Okay, this depend upon your data analysis. How good your data analysis is, training model will be good and your output will be good, right? So everything is dependent on each other's steps, right? If this is good, this output can never be fail. but your focus should be on this to improve the your prediction or forecasting, whatever you are going to do for your test model, for your new data. This is your main goal. It should be good. Your output should be, if your training model is working 80%, 85%, don't get happy. If it is going to be even 84% close to your this one, then you should be happy because this is your goal. Tomorrow your model will be deployed in the market. This is going to be work, right? This is going to be used by your model, by the customer. This is what your stakeholder want. They don't care about how did you train the model, right? They care about this output, how correctly your model is predicting the thing. Okay, and this is all depend upon your data analysis, again I'm saying. Okay, and this is the reason you need to split the data into two parts: train and test split. In short, this is used to train the model, this is used to test the model. Okay, if you still have any confusion, please post your question. This is little bit technical and little bit I understand this is hard to understand at a beginner level. Okay, I'm ready to repeat it if you still have any problem. Okay, here we will clear all in. Here we go. Okay. So the over next session, when I will do the live session, I will explain what is data pre-processing, what is data leakage, and what are pipelines. Because we will use the pipelines in our all machine learning coding sessions. Okay. This is the very good and you should use it because it will fasten your pre-processing steps. But before that, you should be aware with the data leakage. Okay. You should be aware with the data, what is data pre-processing. Okay. So what I will do now, tomorrow we will do the live session again on these topics. Then I will pick up one data set which contains the values, some missing value in the categorical numerical, and then we will I will show you how to use the pipelines. Okay, but I will not pick up the data leakage problem right now in the coding session. I will pick up it in the my next live coding session. Okay. I will try to do the maximum live sessions instead of the recorded session according to your feedback. Okay. And this is all about our today's session. I'm going to stop sharing and I will jump onto the here. If you have any question, feel free to ask, feel free to ask the question and post your queries as much as you can. Okay. And thank you so much for watching this session. See you in the next session.